Hello, welcome to yet another episode where we shall be looking at the Limpopo Paper 1 Mathematics, the prelim, September 2024. Okay, so if we start with question number 1. Question number 1, they're telling us to solve for x. Okay, so 1.1.1, telling us x squared plus minus 3x plus 2 is equal to 0. So we can find the factors in this case. So we can start by opening the brackets. That's going to be x minus 2 and x minus 1 is equal to 0. If I open this up, I get to that. So which means x is going to be a 2 and x is going to be a 1. So those would be the two solutions for that case. Then we look at 1.1.2. We have 3x squared minus is equal to minus 2 minus 6x. And then there's a condition that tells us that we must round our answers to 2 decimal digits. So this requires us to use the quadratic formula. But before we do that, we need to create the standard form or the standard equation where we move everything to one side of the equal signs. So that's going to be 3x squared plus 6x plus 2 is equal to 0. Okay, let me just jot to this side. We're saying 3x squared plus 6x plus 2 is equal to 0. Okay, so my A is a 3, B is a 6, and then the C becomes a 2. So from the quadratic formula, we know that x is equal to negative b plus minus square root of b squared minus 4ac. Everything is over 2a. We do the substitution. It's going to be negative 6 plus minus square root of 6 squared minus 4 multiplied by 3 multiplied by 2. Everything is over 2 times 3. Okay, so I can punch this into my calculator straight away. And then I'm getting first answer as negative 1,58. Or I switch the sign, I'm getting a negative 0,42. So that is 1.1.2. And then 1.1.3, where we have a surd. Condition number 1, we need to isolate the surd, and of which in this case it has already been isolated for us. Okay, the next step is for us to square both sides. So we shall square here, and then we square this side. So the purpose of squaring is so that we can kill the root sign. So we're going to have 2x minus 1 squared is equal to 1 minus x. Done. Then we just have to open up the square bracket. This is 1.13. So that's going to be 4x squared minus 4x plus 1 is equal to 1 minus x. We can transpose everything to one side of the equal signs. So we know that this one and this one will go. And I'm going to have 4x squared minus 3x is equal to 0. So I'll factor out what I see as common. Okay, so I'll take out the x. I'll be left with 4x minus 3 is equal to 0. So either x is a 0 or x is a 3 over 4. So now the last step is for us to test which of the values between these two will satisfy the original expression. So it was 2x minus 1 is equal to the root of 1 minus x. So if we replace x with a 0, on the left-hand side, we're going to have a negative 1. And as much as on the right-hand side, we shall have a 0. So these two are not equal, okay? So which means we're going to cross this out and say not applicable. When we try 3 over 4, so what is 2 times 3 over 4? And that's going to be 3 over 2. We subtract 1, because that's going to be 6 over 4, which is 3 over 2. And then we subtract 1, which is going to give us a half. We try that side, 3 over 4 subtracted from 1, that's a quarter. Square root of a quarter is a half. So which means that is the solution that we need. All right, then 1.1.4 is the inequality. So let's get the critical values straight away. So our critical values will be -3 and a +3. Okay, -3 and a +3. But now, if we open up these two brackets, we're going to see that our A is going to be a negative. Okay, so which is more like a frown graph or a frown parabola. And if -3 and 3 are basically our points, more like the roots, for us to find where this expression is less than 0, in other words, it's below the x-axis, we're going to say x should be less than -3, or x must be greater than a +3. This is one way of representing that. Alternatively, you can draw your parabolas. Okay, so that's a -3, and then this is a +3. And then you do the shading in that sort of manner. All right, so that is what would happen in that case. Okay, so I'm choosing to work it out in this format. And then 1.2. 1.2, they want us to solve for x and y simultaneously. So if we call this equation 1, we call this equation number 2. Equation 1 is the linear equation. Let's make something the subject. Y can be easily made the subject. Let's move the 2 that side, which means y is going to be the same as 2x minus 2. Let's call that equation 3. And then we have to substitute equation 3 into equation number 2. Let me jot this side. Y minus 2 is equal to x squared minus 3x. And we said y is 2x minus 2. Perfect. All right, so that is 1.2. Let's do the substitution. Let's do the substitution. Okay, so where there is y, we're going to replace that. So it's going to be 2x minus 2. We're subtracting a 2 is equal to x squared minus 3x. Why is it so direct? Okay, it's fine. We open that up, it's just going to be 2x minus 4 is equal to x squared minus 3x. Let me transpose everything to the right. I'll have x squared minus 5x plus a 4 is equal to 0. I'll open this. Vectors of this will be x minus 4, x minus 1. So which means my x is a 4, or my x is a +1. And then I'll substitute these x values into equation number 3. So from equation number 3, it definitely tells us that the y is going to be, if x is a 4, that is going to be 2 times 4 is 8 minus 2. Y is a 6, or y is going to be a 0. Because 2 times 1 is 2 minus 2. It's a 0. So that's how we would claim those 6 marks. It was a bit straightforward. All right. All right, 1.3. They're telling us that an athlete calculated that if he increases his current speed of x kilometers per hour by 5 kilometers per hour, he can reduce his time by 12 minutes. This guy will be participating in the city marathon in Polokwane, which is 72 kilometers per hour. Determine the value of x. Okay, so let's see. We know that the current speed is x. Okay, the new speed is gonna be x plus 5. This is kilometers per hour. Then the current time, we don't know it. And then they're telling us that the time is gonna reduce by something like 12 minutes. So let's do the conversion of 12 minutes into hours. That's gonna be 12 over 60. By 12 is 1, by 12 is 5, which is like 0.2. So I can say t minus 0.2. Okay, so the distance they gave us is 72 kilometers. So this 0.2, I had to convert it to hours so that everything just moves within the same units, kilometers per hours and hours. So I cannot use minutes the way it is. Then let me express time in terms of distance and the speed. We know that speed is distance over time, so which means the time is going to be distance over the speed, so which is 72 over x. So this is our time, which means that our new time here is going to be 72 over x minus 0.2. The distance is still going to be 72 kilometers. Whether it increases the speed or not, still the same distance. Okay, so let me use the new data and see if I can get that x value. So I'll say speed is distance over time. Where there is speed, I'll put the x plus 5. The distance is 72. And then the new time is 72 over x minus 0.2. So I'll cross multiply. I will cross multiply. I'll have x plus 5, multiplying it by 72 over x minus 0.2 is equal to 72. So x and 72 over x is just going to give us a 72, 0.2x. What's 72 times 5? That is 0. It is a 360. 360 over x. And then we are subtracting a 1, equating it to 72. Multiply through by x if we so wish, because 72 and 72 will cancel out. That is fine. Then what am I left with? I'll have negative 0.2x squared plus 360 minus x equals to 0. Okay, so I'll have this sort of a quadratic. And then if I'm to look at this quadratic, is it possible for me to solve it? Yes. If I divide through by 0.2, and then transpose, okay, let me just say I'm dividing it by negative 0.2. Divide by negative 0.2. So that's going to give me x squared. What is 5 times 360? I'm getting 1.8. And then this is going to be 5x. Okay, so that is, let me just rearrange it. Minus 1.8 is equal to 0. All right, when I look for the factors, I'll have x and x. This could be a plus 45, and the minus 40 is equal to 0. So x is either negative 45 or x is a 40. But we know that x was the speed. Okay? And speed can never be negative. Therefore, our x is 40 kilometers per hour. All right, so that is that. That is that. Question number 2. The reason as why we're saying x cannot be negative is because speed is a scalar quantity. It's not a vector quantity. Okay, question number 2, they are telling us that the 4th term of an arithmetic is 5, and then the 14th term is 15. Calculate the common difference. So this is more like a simultaneous sort of question. We know that the general term is Tn is equal to A plus n minus 1 into D. Let me just create the equations. So when you talk about T4 is 5. So 5 is equal to A, which we don't know, plus 4 minus 1, which is a 3. Call that equation 1. 14th term is 15. So 15 is equal to A plus 14 minus 1, which is a 13D. That's equation number 2. Then I'll subtract equation 2 and equation 1. So 2 minus 1. So 15 minus 5, that's going to give me a 10. The A's will cancel, and then I'll have a 10D, which means D is a 1. D is equivalent to 1. Then they want us to determine the general term of the sequence. So we substitute. But before we substitute, we need to get the value of A. So replace D with 1, which means our A is going to be a 2. So if I use the first equation, it's going to be 5 is equal to A plus 3, which means A is a 2. And my general term, Tn, let me just write it this side, because space is not conducive that side. Okay, so we're saying Tn is A plus n minus 1 into D. So we say the first term is a 2. Okay, so Tn is going to be 2 plus n minus 1 into D, which is a 1 also. Open that up, 2 plus n minus 1, which is the same as n plus 1. So that is our general term that they're asking for. Then they want the sum of the first 22 terms. So from an arithmetic format or perspective, it's going to be n over 2 into 2a plus n minus 1 into D. So S22 is going to be 22 over 2, open brackets, 2 by 2, plus, that's going to be 21 times 1. So I'll be left with 11 multiplied by 21 plus that is 25. So 11 times 25, which gives us like something like a 275. Okay, then question 2.2, a quadratic pattern has the following properties, okay? So X is the T1. Let me have it in this format. T2 is a 7. T4 is 7X. And then T3 minus T2 is a 6. That is a 6. So which means that our T3 is 13 indirectly, okay? They want us to get the value of X. So let's get this. The first difference here is going to be 7 minus X. And then the first difference here is going to be 7X minus 13. Let's get the second difference. It's going to be 6 minus everything here. So that's going to be negative 1 plus X. Let's get the common difference here. It's going to be 7X minus 19. But one thing we know about the quadratic is that the second difference will always be the same, okay? So I'm going to equate these two differences. So that I have X minus 1 is equal to 7X minus 19. So I'll move the 7 to this side. I'll have a negative 6X. I'll move the one that side. I have negative 18. So which means my X is just purely a 3. All right, question number 3. Given the geometric series, we have 2 over 3, 2 over 9, and all of that. So, which means there is a constant number, which is a 2. Calculate the sum to infinity. So we know that sum to infinity, the formula is given as a over 1 minus r. Our first term is a 2, we know. What we need is the common ratio. So what are they multiplying on the previous term to give us the next term? That is 1 over 3. Okay, because 2 times 1 over 3 gives you 2 over 3, times 1 over 3, 2 over 9, and so on. So let's substitute that. So it's 2 over 1 minus 1 over 3. That's going to be 2 over 2 over 3. And then the answer becomes a 3. Okay, then 3.2. Show that the sum of n terms of the series is given by this. So one thing we know is that this is a geometric. So we've forgotten about the sum to infinity. We're just talking about the sum of the geometric, which is given as a into 1 minus rn over 1 minus r. So our a is a 2. Open the brackets, 1 minus, we said 1 over 3 to the exponent of n. Let me put this in brackets. Then 1 minus 1 over 3. So we're seeing that this 2 and the 1 minus 1 over 3 gives us the sum to infinity, which is a 3. So I'm going to replace this whole thing with a 3. So this is the same as 3. Open brackets, 1 minus 1 over 3 to the n. Open the brackets, that's going to be 3 minus 3 times 1 over 3 to the n. So that is what they wanted for 3 marks. Then 3.3, can we calculate the smallest value of n for which the sum of the first n terms will be greater than 2,99? So from where we stopped, we can proceed with that. So we're going to say that 3 minus 3, everything is 3, okay? 1 over 3 to the n is greater than 2,99. I think I would prefer to use fractions, but it's okay. Let's see how it goes. So I'll move the 3 to that side. I'll be left with a negative 3 into 1 over 3 to the n is greater than. So if I subtract that side, I'm going to have 0,01. But it's going to be a negative number because 2,99 is smaller. Then divide both sides by 3. So 1 over 3 to the n is greater than 0,01 over 3. Now, for me to get n, I can use my logs. So now that this is an exponent, so it's going to be n log 1 over 3 is equal to the log of 0,01 over 3. Then when I divide, it would be the same as log base 1 over 3, and then 0,01 over 3. All right, or we can alternatively say that this log here divided by that log here. You should be able to get the same answer. So the answer I'm getting, why am I using equal signs? Should be greater. Okay, so n is greater than 5, is it 4? No. My calculator is showing me things. 5, let's say 19. The question is asking for the smallest value. So n should be approximately 5. N should be approximately 5 because that would be the smallest value from the answer. Okay, so that is question number 3. Let's move on to question 4, which will be functions. They're telling us that the graphs f of x, which is a parabola, and g of x, which is a straight line, are sketched below. B and C are x-intercepts, and A is the y-intercept. E is a point on F, and so on and so forth. EG is parallel to the y-axis. They want us to get the coordinates of B. So we know that B is a point where two graphs are cutting. And one other unique feature about B is that it's the x-intercept. Okay, so we cannot use G since we don't know the values of G, but we can use F. Okay, so where we have y as a 0, because that will be the x-axis. So where there is f of x, we're going to put a 0. That's going to be negative x squared plus x plus 12. Let's move everything over. It's x squared minus x minus 12 is equal to 0. That's x, I can say minus 4 and plus a 3. So which means x is a 4 or x is a negative 3. They want the coordinates of B. So since B is on the positive side, it will be 4 and 0. 4.1.2, they want the values of M and K. M and K. So for me to get M and K, which is the gradient and the y-intercept, we know that the y-intercept of G is the same as the y-intercept of F. And at the y-intercept, x is a 0. So if x is a 0, y is a 12. So this point is a 12. So we know this is a 4, that is a 12. We need to get the gradient. So 4.1.2, gradient will be the change in y. Okay, these are negative 12 units and then positive 4 units. So negative 12 divided by 4 gives me negative 3. So which means my equation, let me not even get the equation. Let me just get the M. So it's saying M is negative 3, and then the K, which is the y-intercept, is a 12. So that's how you get those marks. For you to get the 12, remember, we substituted here with 0. So F of 0. F of 0 gave us the 12. All right. Then they go on to tell us that if OG is 2 units, let me just change the color a bit. So from here up to here, those are 2 units. Okay. They want us to calculate the length of EF, this distance. So if this is 2 units, which means that G is a point where X is a 2. Okay. So for me to get this distance, I need to get the difference, or I can do the substitution of X is a 2 at this point. What will be the Y? Okay. So that will be, remember, it is negative 3X plus 12. So if I put a 2, my Y is going to be a 6. Then for the parabola, if I replace X with a 2, that's negative 4 plus 2. That's going to give me a positive 10. So the distance in between is going to be 4 units. Okay, that's going to be just 4 units. What we said, the graph on top is F. Get F of X minus the G of X, and then replace everything with 2, where there's X. So it's like negative X squared plus X plus 12 minus the minus 3X plus 12. This is a 12. Okay, so when you simplify that, if you choose to simplify that, that's going to be negative X squared plus X plus 3X. The 12s will fall away. So it's negative X squared plus 4X. Where there is X, we said put a 4. Sorry, put a 2. That's going to be negative 4 plus 8, which gives us a 4. There we go. Then they want the area of AOGF. Let's see. AOGF. So this is a trapezium that we can clearly see. We know that these are 6 units, and then these are 12 units. Our height here is a 2. So we know that area of a trapezium is given as a half height A plus B, where A and B represent the parallel sides. Okay, so that's going to be a half multiplied by 2, which is my height now, then multiplied by the length of A, which is a 6, the length of B, which is a 12. 2 and the 2 will cancel. Our answer becomes 18 units squared. Okay, so that is one approach of getting that. Alternatively, what we can do is we can break down this shape into simpler shapes. Okay, if we have a triangle, and then we also have, okay, so where we can call this maybe shape 1 and call the bottom one shape 2. So the height of this triangle will be the 12 minus 6, which will give you a 6. And then the base is a 2. Then this rectangle is a 6 by 2. You find the areas, add them together, you should be able to get to the same thing. Then 4 point, what's happening? Now it's running. Let's see. 4.1.4. They want the coordinates of the point of intersection of G and F. They're telling us there is a tangent at C. Coordinates of the point of intersection of G and a tangent of F at C. Okay. So if there is a tangent at this point C, and this tangent is meeting up with this graph, what are the points? How many marks is it? 6 marks. Wow. Okay. So what we need to do is get the equation of this tangent. If we can get the equation, then we are set to go. So for me to get the equation of the tangent, I need the gradient of that line of the tangent. For me to get the gradient, I can use the calculus by finding the first derivative of f, so that I get the gradient function at any point of the graph. We already know that the coordinates of C are -3 and 0. This should give us the gradient straight away. So I'll say f prime of x, remember it was -x squared plus x plus 12, plus x plus 12, all right. So f prime of x is going to be just -2x plus a 1. Then if we replace x with a -3, so f prime of -3 is going to be -2 plus times -3 plus 1. This gives us a 7. So the gradient is a 7. Then let's get the equation where we shall say y, because C has -3 and 0. So I'll say y minus 0 is equal to 7 into x minus -3. So y becomes 7x plus a 21. This is the equation of the tangent. Now the equation of the line G is given as -3x plus 12. Now one thing we need to know is that at the point of intersection, the two equations will be equal to each other. So I need to solve this simultaneously. Okay, so I'll say 7x is, why am I just saying 7x? I'm saying 7x plus 21 should be equivalent to -3x plus 12. Let's transpose and collect like terms. That's going to be 10x is equal to, what's 21 minus 12? That's a 9. So that is, why am I getting a -9? Does it make sense though? Does it make sense though? I don't know. Let's just go with it. So it's going to be divide both sides by 10, which is -0.9. Since they want the coordinates, we need to substitute this into either this equation or this equation. So y is going to be -3 into -0.9 plus 12. All right, so that's going to be a 2.7 plus a 12, that's 14.7. So y is this, x is that. So that is how we would have worked out this question here. Then 4.1.5, determine the values of x for which f of x and f prime of x is less than 0. So the gradient and the function itself to be negative. So the graph is below, and then probably the gradient is also below. So we can see that for this to happen, okay, since we're looking at a negative value, the function needs to be negative, and maybe the gradient needs to be positive. Alternatively, if the function is above the x-axis, the gradient needs to be negative. What I mean by gradient is that the shape with the positive, it should be increasing, because that's the gradient basically. And then the graph should be below the x-axis. So where is the graph increasing? Oh, where is the graph deep? Yes, increasing, but below the x-axis. It's from this point. That's where it's below. But this shape is increasing. So we can say that our x is less than -3. Where is the graph above the x-axis and the gradient is decreasing? So it's between, we need the axis of symmetry somewhere. We need the axis of symmetry because this is where the graph is decreasing and it is above. So between this and the axis of symmetry. This is a -3, this is a 4. When we plus the 2, we get a half, no? Because that's going to be our axis of symmetry. -3 plus 4 divided by 2. That's a half. So I'm going to say a half is less x is less 4. So those will be my values for that particular point. All right, then 4.2 are telling us that f of x is 2 over x plus 2 plus 2 again, okay? Then they want us to sketch this graph showing all the intercepts and all of that is required. So one thing we need to remember is that by just the format of this, we know that this is a hyperbola. Okay, let me just decide. It's 2 this is 4.2. Okay, so f of x is 2 over x plus 2 plus 2. Okay, so what we need to do is we need to, one, state our asymptotes. We know that the asymptotes are basically x being -2 and y being a 2. We also need to determine the intercepts, okay? So we know that for y-intercept, x must be a 0. You replace x with a 0, we're gonna get y as a 3. So 0 and 3 become the y-intercept. And then for the x-intercept, we said y must be a 0. So where there is f of x, let's put a 0. And if that's a 0, the 2 is going to move. We're going to have -2 is equal to 2 over x plus 2. Let's cross multiply. -2x plus 2 is equal to 2 divide. Okay, no, let's open up. Let's open up. -2x minus 4 gives us a 2. -2x must give us a 6, which means x is a -3. I think that's all that we need. We have our intercepts, we have our asymptotes. Let's sketch. So I'm going to call that my y. And let's have this as our x. Asymptotes are -2. Let's have it there. That's a -2. And then a +2. Let's have it there as our +2. All right, then 0 and 3. So 0 and 3 is somewhere. Let me just put it somewhere there. So since the A is positive, we expect it to be this first quadrant here of the asymptotes. And then we said X is -3, which is somewhere here. So the graph must just be in that sort of area. All right, so that is our hyperbola that they needed. Then for which values of X will this be greater than -2? Let's rephrase this and form the equation we had. So that would be more like 2 over X plus 2 is greater or equal to 0. So for which values of X would the hyperbola be greater or equal to 0? For which value is greater or equal to 0? So we can see that from this point of -3 to the left, the graph is above the x-axis. So it's above the 0 line. And then we can see also that after this asymptote, the graph is also continuously above the x-axis. So for the two values of interest or the two representations of interest, we can say that X must be less than -3 or X must be greater. They said equal, so I can put an equal sign there. And then X must be greater than -2. So those are the two restrictions that we would have had as far as that question was concerned. Then they want us to determine the equation of the axis of symmetry for which the gradient is negative. So the general equation is -x plus c. For us to get for us to get c, we need to use the points of intersection of the asymptotes, which is -2 and 2. Okay, so this is going to be a 2 is equal to negative with a -2 plus c. So that's going to be a +2, move it that side, c is going to be 0. So the gradient or the equation is just -x. In other words, it's just cutting across, going through that kind of area. All right, so that is question number 4. Move on to question 5, telling us that the figure below shows the graph h of x, which is the log x base a. We have a point A, which is that, and then a point B, which is the x-intercept. Calculate the value of A. So for us to get A, let's substitute this. Let's substitute this and see. So I prefer to always write this in exponential form. So if it is y is equal to log x base A, this is going to be the same as same base, switch, something like that, if I'm writing it in exponential form. So where there is x, I'll put a 16. And then where there is y, I'll put a 4. I can raise using the exponential rules, so which means our a is a 2. But remember, it can be a positive or a negative, and we need to decide. So in this case, it's going to be a positive by virtue of the direction that the graph is going. So it's an increasing one. Okay, then 5.2, write down the coordinates of B. Here, we know that x is what? We're looking for x if y is a 0. So if a is a 2, which means it's 2 to the y is equal to x. If y is a 0, it's going to be 2 to the 0, which means it's a 1. So 1 and 0. Determine the inverse in this form. The inverse. Okay. If I'm to leave it in the log format, either way, it would be y is equal to the log x base 2, which is just more or less the same as this with the 2. Now, for me to change this to exponential, it's just going to be 2 to the x. I mean, we're just switching x and y. Remember, it was this, switch x and y. So it's 2x is equal to y. So that is the inverse. Then write down the range of the inverse. So when we talk about range, the domain of this original function is that x is greater than 0. Now, if we are to draw our inverse, because the 1, 0 is going to be 0 and 1 somewhere here. The 16, 4 is going to be 4, 16. So which means it would be in this sort of section. So since it was greater, x is greater than 0, then this one is going to be y is greater than 0. So that is question number 5 done. Question number 6, the finance. Tapelo and a friend invest their inheritance of 200,000 at 11.5% per annum compounded quarterly. After a period of 10 years, they use their return on their investment to build a house at a cost of this much. They borrow the balance needed to build the house from a bank. And the bank offers the loan at this compounded monthly. And then they must pay the loan over 25 years. Calculate the effective interest rate. So we know that 1 plus I effective is equal to 1 plus I nominal over that. Okay, let's substitute. So which means our I effective is going to be 1 plus 11.5%. We said they're compounding it quarterly to the exponent of 4 minus 1. Okay, so if we do that, the interest effective that I'm getting from my calculator is just at 12%. Then calculate the value of the investment after 10 years. So this is a lump sum. So which means our A is P into 1 plus I to the exponent of n. That's 200,000 into 1 plus, let's use the original. It's 11.5% over 4 to the exponent of 10 times 4. All right, so that is giving me 621,475.37 rands. So that's how much the investment is worth after a period of 10 years. Then determine the loan amount that they will need to finish the house. So they build a house at a cost of this much, 1,815,000. So let's subtract the 1 million and that, and let's see what we get. So 850,000, we subtract in the 16th one, 475.35. Okay, so this gives us 1,228,524.65. No, this was a 37. So that is a 63. All right, then calculate the monthly payment. So if this is the loan amount, so that's the present value. We have all the other details. Let me put it this side. Okay, so this is 6.4. So our present value is 1,228,524. We said 63. Our interest rate, we know that it is 12% compounded monthly. And then the period of time is 25 years. Okay, so we know that the present value formula is x into 1 minus 1 plus I to the exponent of negative n everything is over I. We're looking for X, which means it's PI over that entire big bracket. Let's substitute. So 1228,524,63 multiplied by 12% over 12 over 1 minus 1 plus 12% over 12 to the exponent of 25 times 12, but negative. All right, so I punch this into the calculator. And then I'm going to get 12,939.12. Okay, that is question number 6.4. 6.5, I get balance on the loan after 15 years. So we had 25 years. Okay, if there was 25 years minus 15, which means we left with 10 years. So we need the outstanding balance. So outstanding balance, we still use the same present value formula, which is X 1 minus 1 plus I to the negative N. Everything is over I. Let's do our substitutions. So the monthly payment is 12939,12 into 1 minus 1 plus the 12% over 12 to the exponent of negative 120. Everything should be divided by the 12% over 12. All right, so if we punch this into our calculators, we're going to end up with 9.8. So that will be the balance that is outstanding. Then determine how much interest they will pay on the loan in 25 years' time. So for us to get the interest amount, let's get how much they're paying per month. Okay, this is 6.6. So 12,939,12 multiplied by, we know that 12 times 25, that's a 300. We subtract the initial amount that they borrowed, the 1,288,524,63. Simplify this. These guys are gonna pay a lot of money. So 2 million is what they're paying in excess as interest. So guys, that's the finance question. Question number 6. Question number 7. They want us to determine from first principles the first derivative of 3x squared. Okay. So this is 7.1. Let's kill it. Let's kill it. So f of x is 3x squared, which means fx plus h is going to be 3 into x plus h squared. We know that the limit as h tends to 0 of f of x plus h minus f of x over h. Okay. So we're going to have 3 into x plus h squared minus the 3x squared. This is over h with the limit as h tends to 0. We open this up. So that's going to be x squared 2xh plus h squared minus 3x squared. We're dividing everything by h. The limit as h tends to 0. That's going to be 3x squared plus 6xh plus 3h squared minus 3x squared. Everything is over h. And this is the limit as h tends to 0. Okay. We break this down further. So the 3x's are going to cancel each other. We just left with this. Let's factorize out the h. So h into 6x plus 3h over h. This cancels that. And then replace h with a 0. So This gives us just 6x. That's our final answer. All right, so that is 7.1. 7.2.1, they want us to find the first derivative if f of x is x6, x5, x4, x this. Wow. Let's chow this one also. Let's kill this one too. So we have x minus 1 into, we said x6, x5, x4, x3, x2, x, they said minus 1. No, plus 1. So let's open up this brackets. So if I try with x alone, that's going to be x to the 7 plus x to the 6 plus x to the 5 plus x to the 4, x to the 3, x squared plus 1x. Now I'm subtracting everything. Minus x to the 6 minus x to the 5 minus x to the 4 minus x to the 3 plus x squared minus x minus 1. All right, it's party time now. So we know that this is cancelled with that, this cancels with that, this cancels with that. Party time, this cancels with that. What's happening with the 1? I don't know. We have x to the 7 minus 1. Then we differentiate this because this is now our new f of x. So if we differentiate this, that's going to be 7x to the 6 as our final result. All right, so that is how we would have killed that one also. 7.2.2, they want the x of this. So whenever you have such, factorize out what seems to be common. On top, I'm seeing some bit of x. Something is common. So I'll have x squared plus 2x plus 1. Everything is over x plus 1. Okay, I can still factorize the top one, but that's the same as just x plus 1 squared. So I'll have x into x plus 1 squared over x plus 1. Then we cancel out. This one bracket is killed with that. Shall be left with just x squared plus x. What I mean is that it's going to be x plus 1, and x plus 1 over x plus 1. So this cancels that. Open up, we have that. So the first derivative of this is going to be 2x plus 1. So that's the dx. Then they want us to find dy dx if. Same story. Let's change these two exponents and let's remove this x and take it on top. So that's going to be x to the 1 over 3 minus 1 over 3 x to the negative 1. We cannot differentiate when the x is a denominator. At least we should make it a numerator at our level now. All right, so this first derivative dy dx is going to be 1 over 3 x negative 2 over 3. The negative and that will give us a positive 1 over 3 x to the negative 2. No one said that we must give our answers with positive exponents. Leave it there, and then we move on. So that would be our result. All right, then question number 8. Removing. Yes, okay, question 8. We have f of x, which is 2x into x squared minus 9x plus 24. Can we show that P is 336 the point on the graph? So for us to show this, where there is x, let's put a 3. And our result should be a 36. As simple as that. So that's going to be f of 3. It's going to be 2 times 3 into 3 squared minus 9 times 3 plus 24. I know that 2 times 3 is 6. Into, that's going to be a 9 minus 27 plus a 24. This and this is negative 3. Okay, 6 into 9 minus 3 is a 6, which gives us a 36. Just show that. Do the substitution of x, get the y. Then 8.2 can get the coordinates of the turning points of f. So for us to get the turning points, we need to get the first derivative of this. But let's start by opening it up. Let's open up that. So this is question 8. Okay, opening up that. Remember, it's a 2x into x squared plus 9x. Is it a plus or a minus? It's a minus. Minus. It's a minus. Minus. Let's kill this one also. Oh, open this up. We have 2x cubed minus 18x squared plus 48x. That is our cubic function. Let's get the first derivative and equate it to 0 since we want the turning points. So it's going to be 6x squared minus 36x plus a 48 should be equated to 0. Divide through by 6. X squared minus 6x plus, I'm getting 8 if I divide 48 by 6. Okay, let's open this up. X minus 4, x minus 2. Does that make sense? Perfect. So x is either 4 or x is a positive number. But remember, these are just x coordinates. We also need the y coordinates. All right, so with the y coordinates, we just substitute x with a 4. That's going to be 64 times 2. That's 128. That is 16 times 18. That's a big number. Let me use my calculator once, straight away. That if I substitute the y's for the y of 4, I end up with a 32. And then if I put a 2, that's 8, 16 minus that plus 96. I have a 40. Okay, so those are the coordinates of the turning points. Then they want us to draw a neat sketch, indicate the coordinates of the intercepts. They said any. Okay, and the axis of the turning points. 8.3. All right, sketching the cubic function. So originally it was 2x into x squared minus 9x plus a 24. If I equate this to 0, which means x is a 0, is a point, it's an intercept. And then when I try to solve this, x squared plus 9x plus 24, which numbers are going to give me 24? We have 2 and 12, 3 and 8, 4 and 6, but nothing gives me a 9. So which means there are no factors here. Okay, perfect. If there are no factors, let's look at the shape. So since the a is positive, the a is greater than 0, which means it's going to be a frown and then a smile. Okay, so if I have my y, then I have this as my x. We say the turning points are going to be 4 and what? 4 and 32, 2 and 40. 2 and maybe 40, somewhere there. And then we said 4 and 32. 32 is slightly below. But remember the shape? This is how the shape is going. So automatically this has to be the maximum. And then that has to be the minimum. Let me just put it there. Remember, it's a sketch, né? And this must cut through the origin, the 0. So by the look of things, I feel like this is our sketch for F. Something like that. Okay. Then determine the values of K for which this will have 3 unequal roots. Now remember that for us to have unequal roots, it's like this whole function must be dropped down. Remember, this is a 32, and then this is a 40. So it has to be dropped down a number of units. If you drop it 40 units down, then this turning point here will be exactly here. So we don't want it to be below 40. If you drop it to exactly 32, then it's just going to have 2 points. Okay. So what we can do, or what we can say, is that our 32 should be less than k, less than 40. In other words, k should be in between these values. Okay. If it's bigger than that or smaller than that, then definitely we're going to have a problem. All right. Then determine the maximum value of f if x is between 0 and 5. Wow. They want the maximum if it's between 0 and 5. So the highest point that the graph has reached between these 2 points, between 0 and 5. It has to be this one, the maximum. Which maximum is at a 40? I don't know why they asked that question. That is a 40. No, maximum is a 40, because that's the highest point. All right, then question number 9. Mashudu Business Enterprises has asked you to design an advertising disc that consists of 2 circles and has a shape as shown below. The larger circle has a radius r and the smaller circle has this. The value of r and r must vary, and r plus r must be 200. The distance between the centers is 200 millimeters. So to minimize costs, the business also stated that the area of the shape must be what? Must be minimum. Area of the shape must be minimum. So the area of this and the area of that. Show that the area of the figure below is given as this. Okay, let's see. We know that area of the bigger circle is going to be pi radius squared. Area of the smaller circle is going to be pi radius squared. If we plus the 2, then we have the area of the shape. Okay, this shape 8. Now, how does it get to that? So remember, we are adding. So that's going to be pi capital R squared plus pi small r squared. This marker is doing me. Okay. So what's common is the pi. Then we have r squared plus a small r squared. But now how do we relate? When I look at our formula, we don't have a small r. So which means let's make the small r the subject there. So that the small r is 200 minus the capital R. So r pi into r squared plus 200 minus r. Everything is squared. So it's going to be a pi. Let's open up. That is r squared. That's going to be 40000, which is 40,000. Yes, that's what I'm getting. 2 times that, that's going to be minus 400r plus r squared. So r squared and r squared, we have 2 r squareds. We can take out the 2. So it's pi into 2r squared minus 400r plus 400. No, it's 40,000. Hello. Take out the 2. So it's 2 pi into r squared minus 200r plus 20,000. And that's what they have. Beautiful. Okay. Then determine the values of r and r if the area is to be minimum. So whether the area is minimum or maximum, we have to do the derivatives. Okay. So let me just open that up nicely without any issues. We said it is 2 pi r squared. Let me open their equation. Minus 400 pi r, okay, plus 40,000 pi. That is correct. And we say that we need to differentiate this. Okay, this is 4 pi r minus 400 pi. 4 pi r is equal to 400 pi. Divide both sides by pi. 4r is 400, which means r is 100. Then small r, we said it's 200 minus capital R. So 200 minus 100, which means that even the small r must be 100. I don't know how, but that is what I'm getting. Hence, explain why the shape suggested by the company is not possible if you want to maintain a minimum area. I mean, if the capital R is 100, how can a small r also be 100? Let's explain it. So what we can do, or what we can say, is that the two circles, okay, do touch externally. Two circles are touching externally. And remember, the company said they want to minimize what? The area. But the area must be minimum. But there is no way the area will be minimum if the two circles are basically touching each other. If one was within the other, then definitely it would make much more sense. Aaron, that is my explanation. Can always put yours under the comment section. 10.1, probability of A is this, probability of B is that, determine A or B if A and B are mutually exclusive. So we know that probability of A or B is given as probability of A plus the probability of B minus the probability of A and B. Now, if events are mutually exclusive, this end will automatically be a 0. So that's going to be just 0.45 plus 0.25 minus a 0. That gives us 0.7. Okay, that's 0.7. Then 10.2, a survey was conducted in one of the schools in that province with a population of 50 educators. 30 of the educators indicated that they each own a car. 2 educators were randomly selected one after the other without repetition. She represents the information on a 3 diagram. Okay, so the first one, he told us that, how can we say? Let's use C for the car and no car, or F for Mitsubishi. All right, no, it's fine. So, second option, you can own a car or you don't have a car. You can own a car or no car. So with the first educator that they selected, chances are high that this educator owns a car. So 30 indicated that they own a car out of 50. So that's going to be 3/5. Automatically, that will be a 2/5. If I simplify, then if the 30, or from the 30 that have a car, one is taken out, we're going to have 29 that have cars over 49. Then for those that don't have cars, will be still 20 over 49. If the first educator chosen had no car, then for those that had cars will be 30 over 49. And then this is going to be 19 over 49. All right, so that is that with what they needed and the probabilities thereof. Then find the probability that only one of the educators selected owns a car. In other words, we want NC or CN. At least one educator owns a car. So that's going to be 3/5 times 20 over 49 plus 2/5 times 30 over 49. We simplify this. I'm getting 0.41. Find the probability that 2 educators selected each own cars. So we want CC. So it's 3/5 times 29 over 49. And that is going to be 0.36. All right, and then 10.3. So you require a password for an online account. The password must have 3 numerical values followed by 2 vowels. How many possible passwords can be obtained if repetitions are allowed? So numerical values, which means we have 10. So that's going to be 10 times 10 times 10. And then we must have only 2 vowels. So that's going to be 5 times 5. Okay, that is 25,000 passwords that we can get. Okay, then determine the number of possible passwords with the following conditions. 1, repetition is not allowed. The password does not start with a 0. And then lastly, the password ends with a vowel. So we have 5. If it ends with a vowel, which means we have 5 options to select. Okay, so we have 5 options of the vowels, but out of the 5, we need 1 vowel here. So which means it's just a fixed number, which is a 1. How many vowels are we left with? They are just 4. With the numbers, going to be 10 times 9, and then times, they say the password does not start with a 0. So which means we cannot have 10 options. We have 9 options start from, and then the next one will also be 9, then the next one will be 8. Let's multiply that. Okay, so I'm getting 12, 9, 60 as my final answer. So that is question number 10. And I believe that is the end of the paper. So I'll stop there and appreciate you guys for following. And if there are any errors that we made, please, you can highlight them in the comment section. We shall fix them. Your positive feedback helps us. Okay. So overall, we can say the paper was fair enough. It was fair enough. For those that have not written, please and please, all the best. I sign out.